Dear guests here in this room and also online, of course, it's an exciting day today. It creates new opportunities for science in this world that has been shaken up so much lately, with strong impacts on polar science and policy, as we heard from other speakers. The Swiss Polar Institute was founded in 2016 and has obtained in 2021 the status of the so-called Article 15 institution. You've heard it, a national research infrastructure supporting Swiss-based polar scientists in their harsh working environment at the 3 poles of the Earth, the Arctic, Antarctic, and extreme high altitude regions. They are difficult to access, but very important, as also we have heard. The climate is actually, it's a very similar situation as we have here. We are on top of the world in different senses at the 3 poles, and it's getting very hot very fast, like it is in this room. And we also know that the polar regions have strong climatological teleconnections, influencing the lower latitudes, including Switzerland. They are of major geopolitical importance and might contribute substantially to the transition towards green energy, something that is very often forgotten. Just to name a few of the relevant points why the poles also matter to Switzerland. The portfolio of SPI support to scientists includes the organization of expeditions, funding towards logistics and travel for fieldwork, funding for technological developments that can withstand harsh polar conditions, health and safety support, community building and networking events, educational outreach activities, and training opportunities, specifically for early career researchers. Actually, there was one other demand by the community very early on that we now managed to arrange, possible only thanks to the new status supported by the Swiss Federation. Big flagship initiatives based on bottom-up proposals by the scientific community. How does this change the polar science landscape in Switzerland? What are the expectations? Maybe you have your own expectations. Well, what we know for sure is that they provide, for the first time, 2 times 1.5 million Swiss francs to Swiss science consortia for polar initiative, coordination, and logistics. This is what we have. So in order to actually get the best science out of these available funds, we had the proposal evaluated by an international panel using the following 3 top criteria: high scientific quality and originality, potential for innovative, multi to interdisciplinary science output, impact on international and national scientific landscape. Well, we had 4 proposals submitted for evaluation, and they were all of high quality and covered all 3 poles, which was also really nice to see. So we had 2 Arctic proposals, 1 Antarctic, and 1 at the 3rd pole. So actually, the proposals at the call attracted a lot of the researchers in Switzerland. And they attracted new researchers and united a large fraction of the Swiss-based polar research community in very new constellations and setups that we didn't see before here at SPI. So actually, we already achieved many of our initial goals already at the proposal stage. Well, due to funding limitations, only 2 of the flagships made it to the funding stage. And the winners are, of course, Pamir and Greenfjord. Congratulations and a big applause. Well, now come the expectations. What are the expectations for the 2 selected flagships? They will produce new knowledge relevant to solve important questions in polar areas, and specifically not stopping at the science level, but really reaching societal relevance. They will foster interdisciplinary research. You have research groups included from the social sciences, humanities, to atmospheric sciences, and it's really from to, including many others. The flagships will follow open science principles and perform public outreach, and they will increase national and international collaboration and visibility of Swiss polar science. Of course, we know that the flagships are only possible thanks to the international collaborators who work so hard in these projects. As you can see on this graph on the right-hand side, that was just a sketch how we thought at SPI that this flagship could look like in terms of the structure. There is a lot of work in front of the flagship PIs and the consortium to set up the structure, the logistics, safety concept, project and data management, outreach, and foremost, to acquire additional funding to cover the actual costs of researchers who will perform the science. And I understand very much that this is challenging, but I also already heard some rumors that there was already a Synergia project submitted. So fingers crossed at this point that the Synergia proposal will make it to really support your science. Alongside the funding of the flagships, we have set up a supporting structure at SPI, and we are here to help with many of these aspects, if needed. I take this opportunity to thank all the involved individuals, the funding institutions, the SPI staff, the advisory board, and evaluation panel, who together have made this new scheme possible and who will be there to support the flagships in the coming 4 years. And of course, the SPI's appreciation further goes to all international collaborators and their institutions. Without these fruitful collaborations, the flagships would not be possible. Well, it's now time to get out and start it. And it might look a bit scary, like on this image. It's beautiful, beautiful vision, but it also might be a bit lonely out there in the beginning. But being polar researchers, you are used to these conditions, and really all the best of luck and success and safe operations out there at the poles for your important mission. After these introductory words, we actually now come to the most exciting part of this event, which is namely really the scientific content and setup of the 2 selected flagships. We will start with the PAMI flagship that will be presented by Francesca Pellicciotti and Martin Hölzle, the 2 PIs of the PAMI flagship.
Thank you so much. Thank you so much. Shall I do that? Yes. Can I move in the center? No. No, I can't. that is a good start. I understand the tone that SPI sets. It's really nice to be here. It's a great pleasure. It's a great pleasure to be presenting our project, which is called... Yes, then I have all my hands full. Yes, okay, wait a second. It's a great pleasure to be here and to be presenting our project, which is called PAMIR. It's the project that Martin and I lead together in what I feel is a very exciting, is a balance, is effective, and is an elegant joint PI ship. We did all together from the beginning to the end, and I hope we'll keep doing everything together until the end. The name of our project is, so the long name of our project is From Ice to Microorganisms and Humans, towards an interdisciplinary understanding of climate change impacts on the 3rd pole, in short, PAMIR. And I have to say, Gabriele explained very well what the flagships were. When we saw that call, the call that we responded to, we were a bit puzzled, maybe not only us. This is a huge amount of money that goes only or almost only into fieldwork. And so, but it was a great challenge, I have to say. It forced us to think in a very novel manner, interdisciplinary manner. And so what we understood that SPI wanted from us was really to go and collect transformative data. Is this also a pointer? No. Okay, doesn't matter. Transformative data with the potential to change our current understanding of a problem of global relevance, something that no other funding mechanism or agency would fund. And it was also a call for programs, not for projects. So we had to devise something that was highly interdisciplinary, high risk in the global relevance. I said we were very happy to be forced to do that in the end. So why did we focus on PAMIR? The PAMIR mountains, okay, now I will need a pointer. The PAMIR mountains of Central Asia are one of the many mountainous chains of high mountain Asia. You see here in that image. This is the only region on the globe with stable or growing glaciers. This is an incredible anomaly. It's a phenomenon that has been named the Karakoram-Pamir anomaly. And in fact, this figure here shows high mountain Asia. Is many glaciers, every dot is a glacier, and then the current state of their mass. So red, they are losing mass, and blue, they are gaining mass. And you see that everything is, and yellow is neutral balance. And you see that everything is red in that picture, except for the blob, oh my gosh, the blob up there, which is yellow and blue. This is the Pamir and the Karakoram. And this is where we focus our project, on the Pamir. The Karakoram, I've tried hard to go there for the past 4 or 5 years. It's impossible to access. It's mostly in Pakistan or China. And so we focus on the Pamir. So this is a unique cryospheric state, the only glacier in the world growing or stable, as I said. But it's also a super important region in terms of people. This is one of the most vulnerable basins in the world in terms of water resources. What this global map shows are the water towers of the world. That is the mountainous region that support people downstream. And this is work that Walter Imagel and co-authors did, published in 2020. They classified those water towers based on 2 key aspects, their importance and their vulnerability. And you see this is the water tower index from 0, not important at all, to 1. And you see that the Indus, Amu Darya, and Sir Darya are the first 3 most important and most vulnerable basins in the world. And the Pamir Mountains feed the Sir Darya and Amu Darya river basins. So this is really a unique combination of a unique region in terms of cryosphere and what's going on with the glaciers, but also of unique relevance for people downstream, ecosystem, people, and water uses. So given this context, what did we want to do in Pamir? What do we want to do in Pamir? We want to understand the current state of the Pamir cryosphere. We want to understand the causes of that anomaly. And we want to understand the consequences that an anomalous state of glaciers, snow, and permafrost has on ecosystem hazards and water resources for people. This is the consortium that is going to tackle this gigantic, ambitious question. It's a highly interdisciplinary consortium. There are 2 PIs, myself and Martin, as I said already, and 6 research clusters that span from glaciers to permafrost to microbial geochemistry, cryospheric hazards, history of science. We are supported by a number of existing grants, otherwise we would not be able to do. We feel the pressure of having to acquire new grants, that is also very clear to us, but we also are supported very strongly by the international community, which is here on the other side of that, which has supported Pamir really enthusiastically, I would say. This is cluster 1. It's climate and environmental history. It's led by Margit Schikowski, who is in this audience. And the goal here is to drill 2 deep ice cores, and by deep I mean down to the bed, on Fechenko Glacier. Fechenko Glacier is the largest glacier on Earth outside of the 2 poles. And a number of groups wanted to drill on Fechenko. This contained an untapped archive of information, of data about our climate. It was part of the Soviet Union, so it was closed until the collapse of the Soviet Union. Then 10 years of civil war kept the region inaccessible. And then the first field expedition was a joint US and Japanese, which was able to go, and they failed, 2006 and 2009. I hope we will not fail. This is all on Margit. Good luck. But if we don't fail, so if Margit doesn't fail, well, we will be able to get our past changes in snow accumulation, the origin of the precipitation that feeds those regions, and the regional scale atmospheric dynamics that we can use to test a number of competing hypotheses that have been suggested to explain that anomalous state of the glaciers. Cluster 2, this is mountain permafrost. I said many times this region is unique, right? I hope you will believe me at the end of this presentation. There are a lot of ice. There is a lot of ice, clean ice glaciers as we know them. Tajikistan is the country that has the largest proportion of its land covered by glaciers in the world. But there are not only clean ice glaciers, there are glaciers covered by rock, the so-called debris cover glaciers, there are rock glaciers, and there is a lot of permafrost. The fact that there is this expression of ice in all its form is also makes the region unique. In general, you have the tendency to have one expression, one form of ice in different regions. So what we want to do here is to characterize the permafrost distribution across the region, and this will provide the evidence base to understand how permafrost will thaw and degrade in the future. Permafrost melting, destabilizes the slopes, so creates hazards, mobilizes a lot of water, so it has an impact on water resources, but also has the potential to liberate a lot of CO2 and methane that goes back into the atmosphere. So it can be a key contributor to the global carbon cycle. Cluster 3, this is us, is the cluster I lead together with my group. Evan from my group is here today. We want to characterize the actual state of the glaciers and snow in the region. Is this really an anomalous? How anomalous it is, and how anomalous it is, and how heterogeneous is that anomaly? And we want to provide the observational benchmark for climate, glacier, and hydrological modeling. We want to do a lot of modeling here, not only collect data. Cluster 4, this is led by Tom Batten, is microbial biogeochemistry. Streams and rivers that are fed by glaciers host microbial biomes, community of microbes that are unique. And we don't know how different those biomes, those communities are in glaciers, in streams that are fed by glaciers that are in a neutral or growing state. So that is the question that Tommy's group and his group are addressing. And we want to understand what the impacts of climate change will be on those specific microbial communities, and what will be their role. They are key contributor to the carbon cycle, to the global carbon cycle. Cluster 5, this is cryospheric hazard. Simon Allen, I think Simon is only connected with us today. As I said before, the cryospheric expressions, the expressions of ice in the region are very, very special. I've never seen something like this. This is a clean ice glacier. This is a glacial lake that is formed by the melting water. And this is dammed by a very large rock glaciers. Rock glaciers are glaciers that we don't know much about, especially in the region. This unique constellation of cryospheric states create a unique state of hazards. This is also the region, so glacier-like outburst is one, but this is also a region where glacier collapse. And there's the largest amount of glaciers collapsing in this region. So glaciers that really just suddenly, boom, collapse. And we don't know why. And what we want to do is, together with the support of another parallel project, is to create a multi-hazard early warning systems. But before, we need to understand what causes those hazards. And finally, cluster 6. This is the history of glacier science. It's led by Christine, who's also here today, Christine Bichsel. Christine will look together with a group at the history of Soviet glaciology. Those glaciers have been some of those glaciers have been studied for decades by Soviet scientists. And what we want to provide, this is a very beautiful, I feel, picture of the station next to Fechenko Glacier, the glacier that I was showing you earlier. Is now abandoned and is getting apart. But it's again another crucial archive of information. We don't know why Soviet scientists were studying those glaciers, and we don't know whether they were aware that those are anomalous glaciers. And so what Christina wants to find out with her group is, this is just, I find it a very beautiful, this is the inside of the station. It's very moving somehow to see the traces of scientists that have been working there. What Christina wants to find out is what are the historical trajectories in the relationship between politics and the production of knowledge, and scientific knowledge in particular. And I think this really sets a very nice context for our work. And this is the type of archive Christina will be untapping. Again, a very moving picture to me somehow. So we are a very diverse, a big consortium. I hope we are also a strong consortium. I do believe very much in that. There are great people, I have to say. 41 Swiss scientists, 21 Tajikis, and 16 international partners. As Gabriella said, the international community is very important for our projects. We made an effort to be balanced. We have 21 sort of advanced career scientists and 20 early career scientists. And altogether, we want to look at integrating knowledge from this complex system. We don't want to go each of us for our cluster. One of my last slide. This project, we're going to collect these incredible data sets for the next 4 years. But this project is not only about data collection. We have the ambition, and I think SPI's project should have that ambition also, to use modeling and a new generation of models, of advanced models, that can then integrate all those data sets into an understanding of the region that we can then reproduce for the past and project into the future. So this is an ambitious project of global relevance. It's highly interdisciplinary. It entails novel numerical modeling, And it has impacts for people, because that region is threatened by climate change, water scarcity, and geopolitical instabilities. So the main output I really strongly want from PAMIA. I think we all want to do fundamental, groundbreaking science. I really like what has been said before me. I mean, I think Swiss scientists have to have the ambitions to be leaders in international community, but we also want to do impactful science for people. And with this, Martin and I thank you very much for your attention. It is warm.
Thank you very much for providing us such a beautiful insight also to the PAMIA region and the problems that you want to solve.
We all together, because
yes.
I alone, I will never make it.
Yes. We'll collect questions at the end. So I would like to ask Julia Schmale now to come forward and present the Green Fjord project. The floor is yours. Thank you very much, Julia.
Thanks very much for the introduction, and it's a true honor to speak in front of such a select audience and diverse audience as well, and also thank you to the online people who are joining. So it's my pleasure to introduce you to the Green Fjord project. Green Fjord stands for Greenlandic Fjord Ecosystems in a Changing Climate, Sociocultural and Environmental Interactions. And from that title, you can already tell this is a highly interdisciplinary project. And at this point, I'd really like to acknowledge the idea of the Swiss Polar Institute to come up with the flagship initiatives, because there is not that many funding schemes that would allow us to be so interdisciplinary, work across the scientific silos and reach out to maybe regions that are not so easy to reach normally for such interdisciplinary projects. So thank you very much for creating this opportunity. And so I'm just standing here on behalf of a large team, and I'd quickly like to introduce you to our team. So we have different clusters. I'm just going to move here so I can actually see there and be closer to you. So we have 6 different clusters. The ocean cluster on the bottom left is led by Samuel Jacquard from UNIL. So he's our oceanographer. Then we have a biodiversity cluster, which is led by Christy Diner and Loic Pellissier from ETH and WSL. Then we have a Cryospheric cluster, which is led by Andreas Fili from the University of Zurich. We have a human cluster led by Len Chanteloup from the University of Lausanne. And then we have a land cluster led by Lisa Bröder from ETH. And nearly all of us are here, so feel free to reach out and ask specific questions on the science, because I'm just representing the whole consortium. I will not be able to cover it all. I'm there for the atmosphere cluster as well. We also have an advisory board, which I'd quickly like to introduce you to. We have Søren Risgaard, who is based in Denmark for the Greenland Integrated Observing System. So they work on atmospheric, biosphere, terrestrial issues, and we can work with them together to actually think about where to place big monitoring containers in the region that we're working on. So this is a really nice opportunity. We have Yvonne Zonka, who is also here in the audience, who has been a professor in Greenland even for multiple years, and he will advise us on the side of humanities and social sciences. And then we have Josephine Niemann, who is based in Greenland and is with the National Research Council and also the Greenland Institute for Natural Resources. And she's a big link to our partners in Greenland, which is very important for us. And so some really brief statistics. At the moment, we're around 40 researchers. The number is increasing, actually, more or less as we speak, and we're nicely divided 1/3 each between early, mid, and senior career researchers. So when you... Yeah. That was perhaps a bit fast. Okay, so... our underlying research question is, what are the consequences of retreating ice? Now, when you look at Greenland, the first thing you will think about is rising sea levels, because we have the big ice sheet that contributes to sea level rise significantly. However, in our case, we need to zoom in a little bit more to actually see some of the details. And these are the fjord systems. And you can tell by the name Green Fjord, we're focused on fjord systems. And we have highlighted two here for you. So the first one on the right side or your left side, this is a glacier which terminates in the ocean or in the water, so a marine terminating glacier. And the contact between the cryosphere and the ocean there induces certain dynamics which are very important for nutrient cycling and carbon cycling. So the biological productivity is very different in such fjords and higher than in the other fjords, as you can see down here, where the glaciers have retreated so far that they are terminating on land. And then the runoff into the fjord water is very different, and the dynamics induced there is very different. And then the hypothesis is that there is less marine productivity. So this is a very, very important consequence of the retreating ice, maybe something that one doesn't think about immediately when thinking of Greenland and climate change. Votre niveau de batterie est faible. if you have power. So it's about marine productivity, it's about the carbon cycle, it's about the local climate, the weather systems, and livelihoods. And I'm going to explain how that is and why that is. But perhaps why did we pick southern Greenland? There is other areas in the Arctic, like Svalbard, that has fjord systems, Norway has fjord systems, etc. But since this is an interdisciplinary project which has a really strong human component as well, we wanted to go to a place where investigations are really key to actually understand what is happening. And southern Greenland is called by researchers there and the Greenlanders themselves an epicenter of socio-cultural change. Why is that? It's the retreating glaciers, of course. It's changed marine productivity. There is mining projects that now become possible. This is one thing. Airports are being moved around. Towns are being shut down because some of the mining projects are not being realized. Now there's new opportunities. It's not only about fishing. There can be reindeer herding, there can be sheep herding, etc. So there's no new open economic opportunities that come up for these people. And these changes happen extremely rapidly. And this is something we'd like to understand a little bit better and to also help navigate the local people, these fast changing times at the moment. The other point is that fjords are affected by the very many drivers. So we have the warming ocean, we have the retreating cryosphere, we have the warmer temperatures in the atmosphere. And all of these are stressors to this fjord system. So we'd like to understand how this induces the accelerated change and what are the consequences. So this is a very complex type of interaction. And then the environmental change can have very important impacts on the fish stocks or socioeconomic sectors, actually, which are very important locally. Now, putting this in our words or sketches, if you want. So this is what we came up with. This is our mental model of the Green Fjord projects, where you have the air, the ocean, the ice, the land, and all the kinds of different interactions that we have. This is surrounded by the anthroposphere. We have the human factor, and all of this is surrounded by the biosphere. And this explains why we actually have these 6 different clusters. We're pursuing 4 big research questions, and then there is smaller research questions that go below these. Now, I do not want to go into the details, but one key research question is really about the fjord dynamics. So that's physics, cryosphere cluster, ocean cluster, and the biodiversity, so the biodiversity cluster. Then we have one research question which is really focused on the atmosphere and climate, and believe it or not, biological particles can be responsible for cloud formation, for precipitation, which is extremely important for the snow and for the development of the glaciers and weather patterns. So this is obviously very strongly tied to the atmosphere cluster, the land cluster, the biodiversity cluster. Then we have a carbon and nutrient cycle question. So this is the land cluster primarily driving this, but the ocean cluster is very important, the biodiversity cluster as well. And then we have the cultural perception. So how do local inhabitants relate to the fjord landscape and the transformation of it? So this is led by the human cluster, but in very tight collaboration with all the natural sciences clusters. So how are we going to implement that? This is our map that we have, and so we have one super site, which is Nasak, which is here. Then we're going to look at two fjord systems. So you see the lines there that end in the yellow rectangle and the green rectangle. So we have one marine terminating fjord and one land terminating fjord that we're going to investigate. And then we have 3 different communities which we will be working with. So Kakatok, Nasak, and then we have Naswaswak up there. And then we have lots of sampling sites that we have indicated with the triangles and different symbols here. So this is where we will be. This summer we will go and start setting up. So we put sensors in the field, we take samples before we then go for intensive observation periods in the next 2 summers and spring and fall as well. And then working towards a phase out, so not leaving equipment in the field to be sustainable there in that sense as well, or perhaps actually handing over some of the equipment to the local community so they can continue measuring there. Then in terms of methods, not going too much into the detail, but this is highly diverse. So we have photo-voice engagement led by the human cluster with the local population. We take samples which we bring back for analysis in the lab, but we also take really high time resolution measurements in the field, so real-time data. We use satellite images as well, and then we operate a number of numerical models for biodiversity, for the atmosphere, and I would also like to highlight the collaboration with the Swiss Data Science Center, and we also have a representative here in the audience, which is facilitated by the SPI Flagship program, actually. So this is fantastic because we will collect such a diverse amount of data. We'd like to make sense out of it, but the Earth system models cannot handle this type of complexity on such a small scale. So this is really the niche where we can work together with the Swiss Data Science Center. This is to illustrate a little bit how we're imagining and where we're imagining to do the field work. So we have the Cryospheric cluster focusing here on the marine terminating glacier, and you see the different types of installations that will be put into the field. Then very clearly we need a vessel, a research vessel. This is where we very strongly collaborate with the Greenlandic Institute for Natural Resources. You see the logo on the exhaust stack there. The land cluster will probe different streams. So if you zoom into the large picture, you would see lots of streams where we can take the samples. And then we have our super site in Nasak, where we have a really strong collaboration with the Nasak International Research Station, which has been started a couple of years ago, but actually really comes to life this year. And it's really nice because they put a news item on their webpage that they now can host the Greenfjord project. And so we'll be doing much of our research based out of this house. We can store samples, so they give us really nice facilities there. For the atmospheric sampling, we actually have a balloon. You see the topography is very complex, so just sampling on the ground would not be representative, so we need to venture out a little bit more. The environmental DNA to get an idea of the biodiversity is basically everywhere. It's hard to picture here, but imagine they will take any type of sample they can get hold of. Then we'll have the true engagement with the local communities to understand what is actually their type of livelihood: reindeer herding, sheep herding, fisheries, and so on and so forth. And then, of course, we try to embed ourselves into the broader landscape. And this is where we will, or actually are, collaborating already with GEOS, the Geological Survey of Greenland and Denmark. We have different programs here. I mean, you can look for yourself. We're also tied to the International Arctic Science Committee, IASC, and so on and so forth. And of course, the flagship programs have a strong outreach component, so we'd like to give back to the local communities. We don't only want to hear from them, but they will also want to hear from us. So, and imagine you come there with the balloon. This is visible from kilometers around, so you kind of need to explain what you're doing anyway. So this is a nice way of engaging, of course. There will be many students involved in classes, master thesis, doctoral students and so on. Many colleagues from the news or other outreach outlets are already interested in what we're doing, so there will be lots of material available for the general public. And we also hope to engage more with policymakers, because I think it's very important what we're going to find out. We will have stories to tell, and there will be salient messages for the local population and perhaps also for Greenland at a larger scale. And as mentioned already by Gabriela earlier, we're strongly working on getting extra funding. So we've submitted an SNF Synergia earlier this week. We need lots of smart early career scientists, PhDs and postdocs who can help us carry out this work. And with this last image, I'd like to thank for your attention and be inspired. Everybody, the Greenlanders themselves say it's fantastic, it's a beautiful region. So we're really looking forward to going there. Thanks very much.
Thank you very much, Julia, for this wonderful presentation and also for providing us this insight. You know, we are a bit spoiled, I have to say. Doing research in polar areas, we really get to places that are really exceptional.